This is Module 1, Lesson 5. Here we're looking at factors, prime factorization, and an introduction to fractions. So first, looking at factors. We know, for example, that 6 times 7 is equal to 42. So here, 6 and 7 are called factors of 42. In other words, if we divide a number by a factor of that number, the remainder will be 0. So factors go into a number evenly. Let's list all factors of the following numbers. So first I have 12. Well, I find it easiest to first write out that we know simply 1 and 12 are factors because 1 times 12 gives me 12. Now I'm just going to count my way up, checking each number in between 1 and 12. So 2. Well, I know that 2 times 6 gives me 12, so that means 2 and 6 are both factors. Well, 3 times 4 also gives me 12, so those are both factors. At this point, now that I've already looked at 3, the next number that would come up would be 4, and I've already said that 4 is a factor, so since there are no other numbers in between here, I can say I found all of my factors. So 1, 2, 3, 4, 6, and 12 are all factors of 12. Now for 23. So I start in the same way. I know that 1 times 23 is 23. Well, 2 is even and 23 is odd, so 2 won't go in. And then I try 3. Well, if I'm unsure, I can always do 23 divided by 3, either in long division or on a calculator. And I'll see that this comes out as a decimal, so that doesn't work. Then I can try dividing by 4. Well, if 2 didn't work, 4 is not going to work. Dividing by 5, that comes out as a decimal, and I can keep checking numbers all the way up through 23, and I'll see that there are no other numbers in here that come out nice and evenly without a decimal or a remainder. Therefore, the only factors of 23 are 1 and 23. This brings us to a definition of prime and composite numbers. A prime number is a number that has exactly two different factors. So for example, like we just saw, 23 is prime because its only factors are 1 and 23. Those are the only two different factors that multiply together to give me 23. Now, it's important to note that by definition, the number 1 is not considered prime because it only has exactly one factor. 1 can only be written as 1 times 1. Since this is the same repeated factor, we can't call it prime. Now, a composite number is a natural number other than 1 that is not prime. So 1 is considered neither prime nor composite. However, all other numbers may be defined as prime or composite numbers. So let's determine whether the following numbers are prime, composite, or neither. Well, we just said 1 is neither prime nor composite, so here I'll say 1 is neither. Again, that's because 1 only has a single factor. 1 times 1 gives me 1. It can't be defined as having two different factors. Now, 15, well, we should think about what the factors are of 15. I know 1 times 15 is 15. 2 doesn't work because 15 is odd. 3 though, 3 times 5 is 15. So since I have more than two factors, I can say that this is a composite number. Now for 29. Well, I know that 1 times 29 is 29. 2 doesn't work because 29 is odd. 3 doesn't work. I can see if I do 29 divided by 3, I'll get a decimal answer. And I can keep working all the way up, dividing by different numbers to get to 29, and I'll see that there are no other factors. So 1 and 29 are the only factors of 29. Therefore, 29 is prime. Now let's look at the prime factorization of a number. We find the prime factorization of a composite number by writing the number as the product of its primes. It's often useful to do this by creating factor trees. So, for example, let's find the prime factorization of 24. So I'll start by creating a factor tree with 24 at the top. Then I think of any two numbers that will multiply to give me 24. For example, I know that 4 times 6 is 24. Now I know there are many other factors that give me 24. It's okay to start with any of them and you will still get to the same place in the end. Now I ask myself, is 4 a prime number? No, it's not. Is 6 a prime number? No, it's not. So I have to keep going. Now I look at any two factors of 4. Well, 4 can be written as 2 times 2. So I ask myself, is 2 a prime number? Yes, it is, so I circle it. Is 2 a prime number? Yes, it is, so I circle it. Now remember, we had said 6 was not prime, so I have to continue down that tree. 6 can be written as 2 times 3. Is 2 a prime number? Yes, so I circle it. Is 3 a prime number? Yes, so I circle it. So we see that we continue our factor tree until we get to the bottom of each branch being circled as a prime. Then I'll go ahead and I'll write my number 24 as a product of its primes. So we can see that 24 can be written as 2 times 2 times 2 times 3. In other words, I picked off each one of these branches at the bottom that was prime. We also could continue on and write this in exponential notation. You see that I have 3 2's, so I could say that this is 2 to the third times 3. Now for 45. So I do the same thing. I'll start a factor tree with 45 at the top. I'll think of any two factors. Let's see, I know that 5 times 9 is 45. 5 is a prime number, so I'm all done on that branch. But 9 is not prime, so I have to continue it. 9 could be written as 3 times 3. Now both 3 and 3 are prime. Therefore, 45 can be written as 3 times 3 times 5, or in other words, 3 squared times 5. We typically like to write our prime factorizations in order of least to greatest, which is why I started with the 3 as opposed to the 5. Now let's take a look at an introduction to fractions. So in each fraction, let's identify the numerator and the denominator. Remember that the numerator is the top of a fraction and the denominator is the bottom. So first, if I'm looking at 4/5, I would say that 4 is the numerator in the top and 5 is the denominator. Now for 7. Well, 7 doesn't have a top and bottom, it's just the whole number 7. But we should recognize that 7 could be written as 7 divided by 1. Therefore, I now can say that 7 is the numerator and 1 is the denominator. Okay, so now let's write a fraction for the shaded part of each picture. So remember, our numerator will represent the part that's shaded, and the denominator will represent the total number of spaces. So in example 10, I see that there's 1, 2, 3, 4, 5, 6 shaded pieces out of a total of, well, I can see this picture is 3 units by 5 units across, so there must be 15 spaces total. So this piece represents 6/15. For number 11, well, now I have 1, 2, 3, 4 pieces that are shaded in, and this picture is 3 by 4 units across. Therefore, there are 12 spaces total, so this is representing 4/12. Now, number 12 is a little bit different. Here, I have 1, 2, 3 pieces that are shaded in, but notice that these aren't actually pieces of a whole thing shaded in. Those are 3 whole standing alone units. So I would say that number 12 is representing the whole number 3. Yes, it's true that there's a 4th piece that's not shaded in, but this isn't part of some greater whole I'm looking at. So there are 3 whole pieces that I have. Now we have some fun fraction facts. So first, the number 1 in fraction notation can be written as n divided by n for any whole number n that is not 0. So for example, in this picture, I have 12 spaces, and they're all filled in, so we can say that this picture is representing 12 divided by 12, which is just equal to 1 whole unit. So the whole picture is shaded in. Now the number 0 in fraction notation can be written as 0 divided by n for any whole number n that is not 0. So in this picture, you can see I have 8 spaces, none of which are filled in, so I have 0/8, which is just 0. Next, the denominator of 0 is not defined for any whole number n. So for example, 3 divided by 0, or 3/0, if you will, is undefined. This does not make any sense. Think about it in terms of what it would mean for division. It would mean that we have 3 objects that we're trying to put into 0 groups. Well, if I have 0 groups, where do I put those objects? They can't just disappear. So that's why we can't divide by 0. Well, lastly, we can say that any whole number in fraction notation can be written as n divided by 1, where n is any whole number. So for example, in this picture, I have 1 whole unit, so I can say I have 1/1, which is just 1. All right, let's look at some simplifications using our fun fraction facts. So for number 13, 0/6, well, I have nothing shaded in, so overall, this is just 0. Now, 6/0, well, this is undefined. I have 6 objects that I'm trying to put into 0 groups. There's no place to put them, so that would be undefined. Now, 6/6, well, I have all 6 pieces shaded in, this is saying, so 6/6 is just 1 whole unit. For number 16, 6/1, well, this is saying that I have 6 whole pieces shaded in, so I just have 6. Now let's look at writing a mixed number as an improper fraction. A mixed number is a combination of a whole number and a fraction. For example, 4 3/5 is the whole number 4, and then we also have 3/5 of another piece. An improper fraction is a fraction whose numerator is greater than or equal to its denominator. So when we're converting from a mixed number to an improper fraction, first we'll need to multiply the denominator of the fraction by the whole number. Then we'll add the numerator of the fraction to the product from step 1. And lastly, we'll write the result from step 2 as the numerator and use the original denominator. So let's look at some examples. I have 4 3/5 that I want to write as an improper fraction. So first in step 1, I'm multiplying that 5 denominator times that 4 whole number to get 20. Then I need to add in the numerator of that 3. So I can see I have 23 pieces, and those 23 pieces are still out of the denominator of 5. So 4 3/5 is equivalent to 23/5. For number 18, I have 5 2/9. Well, I multiply that 9 by that 5, and I get 45. Then I need to add in the 2 from the fraction, which gives me 47, and I'm going to write this 47 out of the original denominator of 9. So 47/9 is the same thing as 5 2/9. Lastly, let's look at how to convert an improper fraction to a mixed number or a whole number. To do this, we need to start by dividing the denominator into the numerator. Then we'll write the whole number result of that division as the whole number part of the mixed number. Then if there's a remainder, we'll put that number over the original denominator as the fractional part of the mixed number. Now let's look at an example. So for number 19, I want to convert 13/5 to a mixed number. So I'll set up long division, 13 divided by 5. I see 5 goes into 13 2 times evenly. 5 times 2 is 10, so I subtract and I get a remainder of 3. So I could say that 13/5 is 2 remainder 3, but to write this as a mixed number, I'm going to say the whole number part is 2, and I have that remainder of 3 out of the original divisor of 5. So 13/5 is 2 3/5. Now, of course, we could always check our answer by converting back. Remember, to convert back, I'd do my denominator times that whole number part. 2 times 5 is 10. Then I would add that fractional part, so plus the 3, and I get back to that 13 out of 5 as a nice check. Alright, now we're looking at 27/9 that we want to convert. So I need to do 27 divided by 9. Well, 9 goes into 27 3 times, because 9 times 3 is 27, and we see there is 0 remainder. Therefore, 27/9 can be written simply as the whole number 3. There is no fractional part to be part of a mixed number.